Fine. So if we're just setting an equation for feedback voltage, the feedback voltage will be defined as minus bit times of V naught, where this minus sign is in accordance with this 180-degree phase shift between your output voltage and your feedback voltage. Okay, so I can write this equation for your VF now as VF is equals to minus beta into V naught where V naught is nothing but AV into VI. So I'm just using this expression over here, AV into VI. Okay. Then in this further steps, I can just write over here. Now, as I know that if I write it one more step over here for your simplification, minus beta AV into VI. Okay. Now, if as I know that if the feedback voltage, I'm just saying over here, if my feedback voltage is same as that of the input voltage. So this is my assumption. This is my assumption. The feedback voltage is same as that of the input voltage. If this is a case, then what can happen? This becomes my VI is equals to minus beta into AV into VI. So VI on either side get cancelled, giving out 1 is equals to minus beta into AB. Now, if I take the magnitude on both the sides, it means what? Let me say mod on both the sides. So mod of 1 is equals to mod of minus beta into AB mod. So this implies that AV into beta should be equal to 1. AV into beta should be equal to 1. Or in other words, if I want to write this in terms of the complex form, I can also write this as mod of AV beta is equals to 1 plus j times that of 0. So what does this indicate? This indicates that the magnitude should be equal to 1 and phase angle should be equal to 0 degree. So this is AV beta. Now, so this is what is the condition for my Bark-Hussein criteria for sustained oscillation. Now, if I want to define this equation in terms of your statements, let me say that the equation that I've derived over here, mod of AV beta is equals to 1 at an angle of 0 degree. If I want to define this in terms of a statement, I can simply say over here, stating that the first term is about the magnitude. What magnitude is this term one speaking about? This one is saying that it is a closed loop voltage gain. This one is talking about, this term is very, very important. Okay, this term is very, very important. The term is saying that the closed loop voltage gain should be unity, nothing but 1. And second thing is talking about the phase shift. It's saying that the closed loop phase shift should be 0 degree or 360 degree. It should be 0 degree or 360 degree. Right? Now, what is that? To be frankly speaking, I don't want to leave this Bark-Hussein criteria over here itself. I want to do some more analysis on that, prior to which I want to make you people something thorough about this topic. Because if your base is strong, I can make you people understand RC phase shift oscillator, LC oscillators in very depth. Okay. Now, what this topic wants to see over here is, so here is your amplifier. Okay. Here is your feedback circuit. Here's a feedback circuit. Okay, we are connecting output of your amplifier as input to feedback, output of feedback as input to your amplifier. Okay, now my question to you people now, my amplifier gain is, let me say that 20. What should be the gain of my feedback circuit? If at all this circuit should work such that it should be producing an output signal, which is a sustained oscillation signal. It's an sustained oscillation signal. If this is the case, what should be the gain of your feedback? What should be the gain of your feedback? Because I want you people to understand this term. That's the reason I'm asking you a question. Because if I start saying in terms of theory, I don't feel it will be impressive. What should be the gain of this feedback so that this entire circuit can work like an sustained oscillator? Good, Archana. This feedback circuit should have a gain of 1 by 20. Understanding? Why? Because I know that the closed loop voltage gain should be equal to 1. The closed loop voltage gain has to be 1. I simply mean to say, I know the closed loop voltage gain will be equal to the gain of an amplifier into gain of the feedback circuit. The gain of the amplifier is what? 20. I want this fraction somehow it should become equal to 1. Then it means my feedback should have a gain of 1 by 20. Then this 20 get cancelled, giving out 1. So at all conditions, this gain should be equal to 1. I simply mean to say you now, if AB in general is a voltage gain of your amplifier, beta, the gain of a feedback circuit will be always equal to 1 by AB. Will be always equal to 1 by AB. So that in a closed loop, this will be equal to 1. This will be equal to 1. Understanding? Is it clear to you? Is the first statement clear to you? Is the first statement clear to you? Okay. So now, second statement. What is the second statement saying? The closed loop phase shift should be equal to 0 degree or 360 degree. What's the meaning of this? Now, it all depends about how is your circuit configuration. How is the circuit configuration? Now, let me say you are never going to decide first an amplifier. Let me make the statement clear. When you're designing your oscillator, you will never decide what amplifier has to be used or in which mode amplifier has to be used. Your amplifier will be decided depending upon the feedback. Understanding? Because if the feedback circuit, if it is producing 0 degree phase shift, my statement to you, if my feedback circuit is using 0 degree phase shift, then what configuration of amplifier will you use? What configuration of amplifier will you use? Good. You will be using an non-inverting configuration. You will be using an non-inverting configuration. Understanding? That is, even this amplifier should also produce a phase shift of 0 degree. That is, it should not produce any phase shift. Okay. But if at all, if the feedback circuit, somehow if it is producing a phase shift of 180 degree, then in that case, you will be using an amplifier in an inverting mode. So that 180 degree from feedback, 180 degree from amplifier, 180 plus 180 is once again 360 degree, which is also equals to 0 degree. So closed loop phase shift produced by amplifier plus phase shift produced by feedback should be always equals to 180 degree, sorry, should be always equal to 0 degree or 360 degree. Is it clear to you? Yes, is the two statements of Bark-Hussein criteria for sustained oscillations. Is these two statements clear to people? Okay. Okay, I want response from all the students. Are you awake or having a daydream? Awake. Okay, good. Okay. So now I'll give a very important statement to you people now. Okay. After which we'll wind up a class and we'll take RC phase shift oscillator tomorrow. Okay. Now this is a very important topic. I could say, in oscillators. I cannot say this as an entire topic, but I can say that a concept related to this oscillator. Now, we say that whenever we are building an oscillator, the value of A beta, that's magnitude of AV beta, what happens to my circuit if the value of A beta is greater than 1? What happens to my circuit when the value of A beta is greater than 1? I can simply show it in terms of a response. I can simply show it in terms of a response. Okay. Now, if the value of A beta is greater than 1, okay, this is your output voltage with respect to time t. If this is your initial signal, as the time passes, it starts increasing exponentially. This is how is a response when A beta is greater than 1. So if you are getting this response, it means your A beta is greater than 1. When I say that AV beta is less than 1, what happens in this case? When I say that when AV beta is less than 1, my signal, which will be an amplified signal, will start decaying like this. Then what will be a case when AV beta is equals to 1? When AV beta is equals to 1, I can say this is output voltage which will time t. I'll be having a sustained oscillations. Understanding? So whether you design an RC phase shift oscillator, you design a Hartley oscillator, a Power oscillator, or even you go for a crystal oscillator, you want your sinusoidal signals to be sustained. So in that case, you have to somehow maintain the value of AV beta is equals to 1. This is the reason why you have to maintain this. If you don't maintain this, then this is how will be your outputs. This is how will be your outputs. Okay. Now, a very important statement which I'll be pronouncing now. When you start your circuit, initially, very initial progressive step, I could say, your AV beta should be greater than 1 initially. Your AV beta should be greater than 1, and system over its feedback, it should be able to get your AV beta is equals to 1. This transition from AV beta greater than 1 to AV beta is equals to 1 should happen in a very due course of time. Why initially it should be greater than 1? In order to increase the oscillation. But once if you get the oscillation, so this oscillation has to be sustained. This oscillation has to be sustained, because right from the origin, it is very difficult to design an oscillator wherein it can have a good amplitude, wherein it can have very good amplitude. So initially, your AV beta has to be greater than 1, so that amplification can go on rising and rising. So after certain instance, this AV beta should be able to transit itself from greater than 1 to is equals to 1, so that you can get a sustained oscillations into the circuit. Okay, is it clear to you? Okay, any doubts about these topics, the topics that we discussed today? Yes, any doubts about this topic? Okay, so if no doubts, then we'll wind up the session. Okay, so tomorrow we'll be discussing about your RC phase shift oscillator. Okay, fine. Thank you.